Hello, thanks for watching this video, Hekwei Sustainability Matters. This topic is EQP3, Indoor Environmental Quality Prerequisite 3, Minimal Acoustic Performance. It only applies to school projects. However, its relevant credit 9, Acoustic Performance, it will apply to all the BD+C project, building design and construction projects. This prerequisite 3, it contains 3 sections: HVAC, background noise, exterior noise, reverberation time. Let's start with the HVAC background noise. HVAC it stands for heating, ventilating, and air conditioning. In classroom and other core learning rooms, the background noise level should lower than 40 dBA decibel. Actually, there is a difference between dB and dBA. dB is SPL, sound pressure level, but the dBA is A weighted sound pressure level. A means we call it 40 weight sound pressure level. B is 70. C is 100. However, we only use dBA, A weighted sound pressure level, but this is not covered by LEED. So if you were interested, please Google it or search it online. Let's continue with the HVAC background noise. 3 standards here. NSI standard S12.6 2010. NSI stands for American National Standards Institute. Second is ASHRAE Handbook 2011 HVAC ASHRAE, American Society of Heating, Refrigerating, and Air Conditioning Engineers. Number 3 is AHRI Standard 885 2008. AHRI stands for Air Conditioning, Heating, and Refrigeration Institute, not the AHRI, the character in League of Legends. Second section, exterior noise. For high noise size, that means peak hour LEQ more than 60 decibels, averaged decibels. LEQ sometimes we use LAT, equivalent continuous noise level. You can measure it by integrating sound level meter or by calculation. For the high noise size, implement acoustic treatment and other measurements to minimize the noise. But for your project, at least 0.5 or 1/2 mile away from that significant noise source, such as aircraft overflights, highways, trans-industrial. This kind of school projects are exempt for this exterior noise requirement. Third section is reverberation time. It means the sound decrease 60 decibel. And the standard is ANSI, the same standard as I just pointed out. The standard part 1, acoustical performance criteria, design requirements, and guidelines for schools or local equivalent. Which one is more stringent or outside the US? By the way, the ANSI standards cost USD 143. Okay, this section 3 contains 2 options. Actually, not 2 actions, sorry. 2 parts. First part is classrooms and co-learning rooms less than 20,000 cubic feet. And it contains 2 options. First option is confirm your total surface area of acoustic, wall panel, ceiling finishes, and other sound absorbent finishes equal or more than the total ceiling area of the room, excluding the lights, diffusers, and grills. The materials must have an NRC more than 0.7. NRC is noise reduction coefficient. Option 2 is the standard that I just mentioned, ANSI standard S12.60, 2010. The next part of the section 3 is for classrooms and co-learning spaces more than 20,000 cubic feet. Here is an association, NRC-CNRC. This is an association name. NRC stands for National Research Council Canada. CNRC is the same thing but in French that I don't know how to pronounce. Uses Construction Technology Update number 51, Acoustical Design of Rooms for Speech, 2002, or local equivalent if outside the US. There are some exemptions here. For limited scope of work or to observe historic preservation requirements will be considered, then it will be the exemption. Okay, thanks for watching this video. Have a nice day. See you next time. Bye bye.